Hi, good morning. This is tutorial session week 12. Go to the eCampus, click at the tutorial chapter 6 under week 12. You're going to answer 3 questions and also upload 1 PDF. The first questions, let the first box which contains A, B, C, D, E, and the second box contains B, D, F, and H. We need to verify the numbers of union between A or B, whether it equals to the number from the box A, number from the box B, and minus the numbers from the intersect between A and B. Means that for this problem, we need to count how many numbers for the left side and what's the number from the right hand side. For the case union A, B, it means that what would be the numbers if we create a Venn diagram to represent A or B. So A, we have A, B, C, D, E inside the box, and then B, we have B, D, F, and H. The center, the intersection area, will contain the same elements between box A and B. There will be B and D. So we need to erase B and D here. Now we want to count how many items or elements inside this Venn diagram. So we'll have 1, 2, 3, 4, 5, 6, 7. There will be a total of 7. Now let us look at the right hand side here. Box A. Let us count. We have 1, 2, 3, 4, 5. So box A we have 5. How about box B? Box B we have 1, 2, 3, 4. There are 4 elements inside there. And we're going to minus the intersection box A and B. That will be what they share the same. B and D. What will be the number? 2 items. Let's check the right side. 9 minus 2, we have 7. And then the left side is 7. Now we have verified this equation is valid. Second question under 6.5. We are given one contingency table, and the table shows us what is the number of the event A, complement of event A, event B, and complement of event B. When we are given this kind of table, we need to find the total for the A, B, complement A, complement B, and also the whole total. Okay. For the A, the total is 40. For the B is 35. For the complement A will be 25 plus 35 is 60. And then the complement B is 30 plus 35 is 65. How about the total from this table? So the total, because there are some complements, so we just need to select one of the either column or the row as the total. So the total will be 100. We'll look at 2 questions. The first is E, and the last one is I. We're going to solve 2. The remaining you try yourself. For the E is event A and complement, and another one is the I will be event A or B. In order to find the probability, we need to know the numbers. For the first case, E, event A and complement B, we need to write in a way of this. A and B. Divide by the N. is we can find the probability of event A and complement B. Now we need to include the numbers inside. We check at the diagram here, the numbers of the event A intersect with the complement B. So let us look at A here, and then the complement B is here. We want to find the intersection between these two events. It is intersect at this number 30. So later on, we're going to replace 30 here, and then NT is the total from those events. Good. Equals to 0.3. So E we get 0.3. How about for the I case? The I case is event complement A or complement B. In order to find the probability, we're going to define the symbols to represent this problem. Or D will equals to, okay, we just take the same expression here, divide by the n total. When we have the union, go back to the first question just now, 6.4, is equals to the n complement plus n-b complement minus n a complement intersect with complement and divide by the n total. We'll insert one by one. The total number of event A complement is under here. So it is 60. The number of the complement B is under here. It is 65. And then the intersect between complement A and B is here. $35. Total is 100. So now we have all the numbers. So for this case, it goes to 0.9. This question is related to the conditional probability, only that reversal. When reversal is needed to solve the conditional probability problem, we need to use additional formula. It is the Bayes' theorem formula. And the formula is a little bit complicated, shown as below here. We look at the question and we will see how can we use the percentage and fit into this Bayes' theorem. T6.6, question number 3. The probability that a person has a disease is 0.03. Okay, we'll write down the percentage. The probability of somebody getting the disease is 0.03. And then a medical test, once performed on this person, normally going to show a positive result. So when this patient go to do the testing, 90% of the time, it's going to show that you got this disease. Next, but occasionally, that is 2% of the time, if a person has no disease, let's say somebody from somewhere goes to the clinic and say, I want to test this disease, can you try? Even though this person is clean, no disease, but the medical test will show a positive result. What is the percentage? It is 2%. How can we write in the probability context here? The probability of tested positive, however, given that he is no disease, is 0.02. Now, we want to calculate the probability that a person is having the disease given that the medical test shows a positive result. So this sounds the reverse of this one, the reverse. So given that this person tested positive, so what is the probability that he got the disease? Given that this person tested positive, what is the percentage that he got the disease? We don't know. So we want to find the reversal of the 90% here. Let's use the Bayes' theorem to solve the problem. Okay, we want to find P D given that the T is tested positive. So the T looks like the A, and the B looks like the T. So we'll fit into the formula here. So the first term is probability of given B over A. So A is T, B is D. So we're going to have this one. Later put inside here. Probability of the B from the Bayes' general theorem here. B is the D for our problem. So probability of getting the disease is 0.03. So we're going to replace inside here. And then P A B is same. We have 0.09. Probability of the B from the formula is equals to the B is D. Okay, so we have it. Replace inside. Next one, plus probability of A complement B. A complement B is this one. Okay, put inside. And the last one is probability of the complement B. Do we have it? B is D. Okay, this one B is D. Okay, this one is equals to P D. So luckily we can use the complement formula to find it. So we have the value for this one, the last one. Then combine all those together, and we're going to get the probability for the requested scenario. Okay, try it. Okay, this is attendance for SBF tutorial. Scan it. This is for the SBH. Scan it. And for the SBB, can scan it. Okay, thank you. So check the eCampus week 13 and week 14 instructions. We will have the session conducted online. Check the details there. Okay, bye bye.